immediately. As we know that in yesterday's class, we have solved what is the basic concept of letters, what a principle of superposition of forces, how it will be, and how to calculate that force exerting or experiencing by a particular part of a body. That is all the things we discussed in our yesterday's class. And yesterday we have solved a question where we have to find the coefficient of x and y, and we got the answer. X coefficient is √7 and y coefficient is what, everybody? 2√3. Am I right, everyone? Please respond. So this is what is the question we studied in the last class. So now let us see the next question similar to that. Now why I am teaching you this question? This is the most important question. It's not the normal question, which will give you the more importance of reading the question very carefully. So this is also a concept which we already studied long back, but there will be an interconnection with that. If you're not remembering that, you cannot solve anything in this. That is what it is. Okay. So let us take, there is a rectangular glass rod or whatever it is. All of you observe, whose center of mass is M. Sorry, COM, and whose mass is M and who is having a length L. Clear, everyone? And there is a mass, point mass M, which is actually A meters away from it. Now the question is, find the force of attraction FG with respect to ground. That is what? Force of attraction between them. That is what is the question. So first of all, what is the force of attraction? If you have taken any two bodies, the distance between from their what? Everybody? Distance between from their centers, which we used to call it as a R, and this mass is M and then the mass is small m. Then we all know that force of attraction is equals to what? Small m into capital M divided by, speak loudly guys, R. Understanding? So always distance we used to take it from where? Mr. Rudreswar? From the centers. Am I right or wrong? Distance between the two bodies from the centers. Now, options, if you have noticed it. So option A, I am giving you. So please make sure you are understanding everything. If not understand, you can ask me. L plus A whole square. Option B, GMM divided by A into L plus A. Option C, GMM divided by L by 2 plus A whole square. Option D, GMM divided by L into A plus L. So this is what I'm giving 1 minute time for you. Let me see, anybody will answer it. I'll make it. Then only I'll proceed further. Make it quick, all of you. Try. You know that force of attraction concept. We use that and try. Then only I'll teach you. Make it quick, everyone. What is your answer? At least you all try. Yes, Pradosh. Are you doing? Laksha, how are you now? Everything okay?
Sir, 1 second, scroll up.
Yes, Pradosh. Everybody has to try. Mr. Kadir, right or wrong, second read. Trying is a basic quality of a student. If you want to progress, please kindly work. That is what is my question. Make sure kindly work, everybody. Yes. Oh, Mr. Narayan, choose the answer C. Okay, Narayan, good. Whatever you have tried very good. Others, Mr. Rishi, Mr. Pradeep, Mr. Murali, I know what is happening. You people need to work. Don't think you are in 11th class. Trying is a basic thing. Try, everybody try. Manya and Samya, you are also. Mr. Rohit also. So now let us see, everybody. So as Mr. Narayan said, Narayan and Prados also, option C. See, Prados, if you are thinking still in a basic level, but you forgot the concept, I'll say. Okay, we'll discuss it now. So let us see, according to them, I'm saying. So they are thinking that mass of this body is M and mass of this small body is small m. So we can say, I think they are taking a distance between the two objects from their centers. So this total length is L means, then from center to this last, it will become what, everybody? Speak loudly, guys. L by 2, and this distance is what, everybody? A. So what is the total distance from the centers, all of you? L by 2 plus A. Am I right, Rudreswa? Pradosh? That is what you have taken. Am I right, Pradosh? So then force of attraction is equals to G into capital M into small m divided by R square. So R square, we are taking G into capital M into small m divided by L by 2 plus A whole square. This is what you are thinking. Am I right, Rudreswa? Pradosh? Narayan?
Yes, sir.
Yes. So if you choose, then option C is matching. So if you go with that and if you click this one, then entirely your answer is wrong. So that is what is I am going to teach you this sum. So be very careful. It is not a body. It is, see, that rectangular body. So you have to be very careful when you are solving like these sums. That is the reason I am stressing here. So let us observe very carefully. If I teach you this concept, then you can remember the concept which we studied long back, the similar thing. So observe very carefully. Suppose if I take this one, all of you see that this is a rectangular glass slab or whatever it is, point mass, and as another mass is m, which is a meters away from the object. Now, all of you observe very carefully. The force of attraction between, suppose I'll make it into small segments. For those, be very careful. So actually we know that this point is what? 0 and this point is what? L. Am I right? Total length is how much? Total length is how
L.
much? L. Okay, so this is ends L starting at the 0. Now you tell me, this body, the force of attraction between these two bodies, is it same between this part of the rod and this body and this part of the board and this body? Is it both remain same? Yes, Mr. Pradosh. If I make it into
No.
let me make it into, it is a dx and this is also dx. If I dm, yeah, thickness is dx or dl, you can take it, and mass is dm and mass is dm. So you can notice here, from here to here, maybe the distance is something x. If I take, like, let me take y. Then from here to here, the distance is what? Between this particle, L plus A total. Am I right or wrong? Speak, respond, everybody. Correct or not, guys? All of you? Yes, Pradosh? That is. So, the attraction between this particle, this point to the point mass and this point to the point mass, is it same? It is not same. Do you understand, everyone? Understand, Udreswa? So it is not same. So you can make it into hundreds of segments. So from each segment, the force of attraction is not same between them. Is it right or wrong? Please respond, everybody. Understand, Ra? Yes?
Yes, sir.
So if I take this one, so let us see how to solve this one. So we all people knows. Okay. So I will make it into, so this is a mass, a point center of mass. Mass is m and length is L. So let me take at this last, I will take it a point segment. So at this point, what is that actually? Let me take x is equals to a. So if I take this point, then the distance between them is, let me consider as a meters. That is what it is. So this is the point mass. Now I'll take a segment here as a dm, and again I'll take it as a segment as a here dm. Now at this point, what is the length? Can you tell me what is the x limits? Here x is equals to a because a is starting here. Then here what is the x? X is equals to what? A plus. This whole length is what? All of you. A plus L. Do you understand that? So that is what. So let me take a particular segment. So from this distance between these 2 points, I will take it as a, let me take that whole distance is x. Clear? So why I'm taking x? I can take from anywhere. Am I right, Pradosh? Do you understand that? I can take from here to here also. This is also maybe a x. Do you understand, Ra? Rudreswa, Narayan? Clear? So that's what I'm taking a 2 parts. This is one part where x is equals to a is the limit. And I'm taking it, and this is the segment where x is equals to a plus L. Will you all agree with me, guys? Please respond. So if I take a small part, then the force of attraction on that particular part due to, understanding, Fm, due to dm mass. Force of attraction on m due to this dm mass. So which is equals to, I will say, capital G into small m into dm divided by, what is the distance between them, everybody? What is the distance between them? X square. So in this step, anybody having doubt, you can ask me. Yes, Pradosh? Tell me, Pradosh. Rudreswa? Yes, girls? Understand, Amma? Narayan? Clear, Narayan?
Yes, sir.
Yes. Now, like this, you may take a segment here. I'm not saying from here. If you imagine from here to here also x, then it will become, that is what it is. So G into, and this particular mass is dm. So this mass is dm and this mass is m. So I'm writing G into dm into m divided by distance between them. I'm taking as a x. So it will become x square. Like that, I can take hundreds of segments. I will write this one is dm1, and this one is dm2, this one is dm3, this one is dm4, like that. So that I will get it. The F net, that is what? F net is equals to, can you tell me, net force is equals to, what will happen? Fm, force experienced by a m particle due to the dm1 mass plus F, the force of m, sorry, the mass of m experienced the force due to the dm2 is Fm2 plus, and force on m due to the dm3 particle is like that, it will goes to up to infinity. Am I right, everybody? Agree with me? Yes, please. If you are involving only, it is very good. Okay. So that's all. It is like that infinity number of segments I can make. So infinity means we can use some formula. What is that? We can use a mathematical concept. Everybody? Integration. So integration of df is equals to integration of gm into dm divided by x square. So now x is equals to limits. Observe very carefully. So up to here, what is the distance actually? Distance between them a. So then x is equals to a. Then this is the segment. If I take it, then this is the total distance. What is the total distance? Everybody? X is equals to what? This is L plus A. What is the limits, Ra? Everybody? L plus A. So limits is A to L plus A or A plus L, whatever it is. Your convenient. Okay. So these are the limits. So if I make it here, G and M is remains constant. So integration of df is F. If you say it is better. So constant I'm taking outside, and integration of A plus L dm divided by x square. So this is what is the integration term, we got it. Okay. Now again we have to use a concept. So if I take again, you can remember this concept what we studied before. So if I take a mass per unit length, that is what is the total one. Am I right, everybody? The mass is L and length is L. Mass is M and length is L. This is what we used to say mass per unit length. Do you understand? If I take whole rod, that is actually the force experienced by them is mass per unit length. We will say that. If I take a very small mass, dm mass, then if I take that segment, particular segment, so whose mass is dm and whose thickness is what? Dx. So I'll say that mass, the force, that is what? This is the mass per unit length. Now you can see here, dm mass of what? Unit dx. That is what? Which is equals to this one. Because sum of this total, if I make into 100 equals to, what will happen? Total mass per unit length. Am I right or wrong? Everybody, please respond, guys. So which is equals to dm by dx is equals to total mass by total length. So dm is equals to, what will happen to this one? Mass by L, total mass by total length into dx. That is what it is. So like these things we already done. Do you remember, brothers? Many questions we have done like this. Taking a small volume and all. Yes or no, guys? Ryan? That is what. So now I will replace it. So F is equals to capital G into small m, integration of A to A plus L. Understand, Laksha? So in place of dm, I will write it as a m by L into dx by x square. So why are I replacing dm? Because is it possible to do the integration dm with x square? Anybody? Because dm is a different term, x is a different term. So we have to modify the dm into what term? X term, dx term. Then only you can do the integration. So mass per unit length also remains constant. I will take that also outside. So G into capital M into small m divided by L. And integration of dx, x square will go up. What will become? X power? Speak loudly. X power? Minus 2. So integration of x power minus 2 into dx. Anybody can tell what is the formula? X power minus 2 plus 1 divided by minus 2 plus 1. Which is equals to what, guys? X power minus 1 divided by minus 1. Am I right, guys? Everybody?
Yes, sir.
Yes. So please respond and do it. So if you have done that, so what will happen, everyone? So which will come as it as a, yeah, x power minus 1. So what is the answer will come? Everybody? Show what is happening. Okay. So let us take now. So what will happen, everybody? X power minus 1 divided by minus 1. So means I will write it as a minus 1 by x. Is it okay, Rudreswa? Clear? This minus will go up. This will come 1 by x. Will you all agree with me, guys? Yes, please. That's all it is. So which is equals to G into capital M into small m divided by L. If you are doing only, it is good. Otherwise, it is not good. So which is equals to integration of this one is minus 1 by x and limits is a to a plus l. So substitute, you will get the answer. So what is happening? Let me take this. Okay. So minus outside, I will put it as a minus. If you just casually I'm multiplying. So I can take it as a minus g capital M into small m divided by L. And this will become roots. I will write 1 by x. So 1 by x means first 1 by a plus L minus 1 by a. So that's all. So do the LCM everybody. So gm capital M divided by L. Here what will happen? A minus L divided by a plus L into a. So that is what. Now you can see everybody. So what will happen everyone? Many things will get cancelled. Anybody can tell? Minus a minus L get cancelled. And this minus into minus will become plus. And LL will get cancelled. So what is the remaining? Everybody? Capital G into small m into capital M divided by a into a plus L. So what is the option which is matching? Anybody? What is the option it is matching? Verify it now. Pradosh? Option? Option? Yes, please. Which option is matching? It's not option C is correct. What is the correct option, everybody? Option B. So that is what you have to remember. Okay, everyone. So why we are using a concept here? Because you are not supposed to take from the center. So because the force of attraction between this segment and this mass is different. The force of attraction between this segment and the mass is different. The force of attraction, this segment and the mass is different. The force of attraction, this segment and mass is different. Because the distance between them is not remains constant. That is you have to remember. So you have to remember, be careful. In this case, what will happen? You take any segment distance between them, I will take it as a x. So then you have to use the integration concept to make the limits. This is the first segment, which is actually starting from a. From here to here, distance is a. So x is equals to a. Then I will take last segment from here to here, the distance is what? This is a, this is L. So x is equals to what, guys? Speak loudly. A plus L. So use the limits, solve the integration concept, you will get the answer capital G into small m into capital M divided by a into L plus a. Anybody having any doubt can ask me. Clear, everybody? All of understand, for those?
Yes, sir.
So please remember that and you have to solve it. So this is a what is very important. Mr. Narayan, understand Narayan? One and Samya. Yes, please.
Yes, sir.
Yeah, please kindly make it. If this question you understand, make it everybody. Clear,
Yes, sir.
Yes, sir.
Brothers, understand, brothers? Anything doubt, Mr. Rudreshwar, Narayan? That's what the brothers. So you have to be very careful. But that concept we studied or not? Do you remember? This is segmentation concepts. Correct? This whatever the concept we used here, every concept it is repeated for us. Do you remember everybody? Yes or no?
Yes, sir. Lambda.
Yes. We worked or not? That's what I'm saying. So it's always there is a relation always. That's what you continuously work. Unless you work, it is not possible. So every chapter is interlinking only. That's what I'm saying you. That is the way 11th and 12th will be there. And you don't know today what we are going to study. Again, next concept, 12th class again it will come. But here we are studying the gravitational field. The first time you are going to be studied. Till now you never experienced anywhere. The same thing. You might be studied magnetic effects of electric current. I used to taught you magnetic field. Do you remember, Mr. Rudreswar? While I'm teaching in the 10th class, magnetic effects of electric current, magnetic field or magnetic flux, the influenced area. Do you remember, everyone? The same thing here. In today's class, we are going to study the next concept is gravitational field. 12th class, we will get electric field. Okay, everybody? Understand, everyone? So exact concept what we are studying gravitational field today. So in 12th class again it will come in place of gravitational you will get electric field. That's all. Okay. Understand everybody? Clear everyone? So we'll start now.
Yes, sir.
So please keep reading. The next concept is the most important one. That is what the gravitational field. This is also the concept for IIT JEE mains and as well as NEET concept. So please keep reading. Gravitational field. It's a very simple concept, but it is like what I can say. This nobody can see that with their eyes. Only they can experience the force of attraction. So that's all it is. G. Gravitational field or strength or G. We all know G means what? Acceleration due to gravity. So that's what it is. So imagine, first itself I'm saying it is an imaginary concept. So you have to remember, you have to imagine, experience virtually, like mind visualizely, you have to experience this concept, then only you can make. So okay. So remember everybody. So let me imagine there is a mass M on in front of you somewhere. So now it is started moving towards in this direction. So there is some invisible force. Like let me imagine there is something like a cloth which is actually having a mass M. So that because of the force of attraction, invisible force of attraction, this mass is started moving towards it. That is what extremely smaller mass. So this mass is in motion towards this bigger one. Let me take for example is a curtain and all. So you can see because of this bigger mass, there is a force of attraction between them. So this force of attraction, basically it is actually what? Invisible. Only we can experience the effect. How we can see that objects are moving towards each other, are revolving around each other. That's what we can experience the effect. So that is why we will say the force of attraction between them because of gravitational, that is what gravitational force of attraction is actually an imaginary field. So if I notice any kind of object, if I take sun is revolving around the moon, sorry, earth is revolving around the sun, moon is revolving around earth, everything is actually a what? It is not possible to see with our eyes. We are just imagining. And you can see without the source, is it possible to rotate the earth around the sun and the moon around the earth? Is it everybody? Or you understand what I'm saying, all of you? So that is what the imaginary force is actually a source. The source actually which makes the body, two bodies to attract each other, attract one another. Do you understand what I'm saying, Mr. Rudreswar? So this gravitational field, the field which is actually invisible, only the bodies will experience it in a certain region. So that is what is actually imaginary field. So this imaginary field is existing because there is a source of attraction when any two bodies will come into the play. Like when any two bodies, if you consider into the in the universe, definitely there will be a force of attraction. So if you remember, just gravitational field means it's nothing a concept. It's just we have to imagine. We have to just feel that concept. So let us take now, if I take any kind of point mass or a test mass, this is what we used to call it as a test mass. We are observing. If it is started moving towards some invisible force, that is what force F. Then what is the strength? The strength of attraction, the strength, how much strength is influenced? That is what the gravitational field, how much strength it is attracting. The strength is only, we used to call it as symbol. Please remember, it is actually the strength of gravitational field. E is equals to force of attraction divided by mass of a test mass, the small mass. So that is the formula, is actually the gravitational field. The strength of a gravitational field, E is equals to F by M. And the direction of gravitational field and direction of force is both always in the same direction. It is depending on the direction. That is why it is called it as a vector quantity or scalar quantity. Everybody, it is the, yes please, all of you, it is the vector quantity. That is what you have to remember it. Do you understand everyone? Please respond guys. So that is what. Now, if you observe very carefully, so for example, so let me take, there is a room in our house, or else you are sitting in a room now. So there is a mass which is actually a 5 kg mass, very small mass. So if you notice it, so inside this room, so if you see that, all of you, so there is a force of attraction if you want to find it. So what is the force of attraction which is acting? So the force F is equals to, let me take it as a 20. And this mass is actually what? How many kg, everybody? This mass is equals to how many kg? Yes, please, 5 kg. Then the magnetic field strength which is E is equal, the strength of the magnetic field is equals to, sorry, gravitational field, F by M, which is equals to 20 by 5. So 20 is the Newton, and this is what? 5 is a what? Kilogram. So which is equals to 20 Newton, sorry, 20 by 5, 5 ones are 5 fours are. So what is the gravitational field? E is equals to everybody. Strength of a gravitational field E is equals to how many Newton? How many everybody? 4 Newton per kilogram. 4 Newton per kilogram. This is
Meter
what?
per second square.
Yes. Newton per kilogram. So now, if you notice this one, so all of you remember, so there is a condition for always a strength of a gravitational field, where a limits, you have to use a mathematics concept, where a limit, where M is extremely smaller mass. If I have taken extremely smaller mass, almost is equals to what? Everybody, 0. So the limit M is equals to 0. So this is the condition, is always we have to, it's like always true for gravitational field. Gravitation, the strength of a gravitational field is equals to F by M, where the limits of a mass is almost very smaller mass, almost approximately equals to what? Everybody, limit M tends to 0. So that is the condition which we are using for gravitational field. Now, if you want to find the acceleration, so how much is the acceleration? So let us see now. So E is equals to, if you have taken acceleration, if you want to find, so we all knows that how much we got it, 4 Newton per kilogram. So I already taught you people, 1 Newton is equals to how many kilogram per meter? Yes, please. kg. 1 Newton is equals to what? All of you. Kilogram meter per second square. Am I right or wrong? Do you remember everybody?
Yes, sir.
Yes. So I will
Yes,
repeat the Newton. So 4 into kilogram meter per second square per kilogram. So what will happen, everybody? Per kilogram. Kilogram will get cancelled. So what is the acceleration, everybody? Acceleration 4 meter per second square. That is what you have to calculate. What is the strength of a gravitational field and what is the force of attraction, that acceleration between the two bodies, you can calculate in this way. So now, that is why the most standard definition of the strength of magnetic gravitational field is equals to F by M. M is almost, what is the mass of M? Is almost negligible mass. That is what is the condition is required. This is the definition of gravitational field. Gravitational field E is equals to force of attraction divided by a mass, smaller mass, where a limit M tends to is approximately 0. So that is what you have to remember. Are you clear, everybody? Understand, everyone? So this is the force of attraction, strength of a magnetic field. Yeah, force of attraction, strength of a gravitational field between the two bodies, if you want to find it. Now, so this field, this gravitational field due to point mass M. So let me take a capital M, I will take it now. So how much it is? Let us calculate it now. So we're having a two masses. One is capital M, another one is what? Small m. So now we are going to see field due to point mass capital M. So let me take it now. So if I take two bodies, one body is capital M, another body is small m. Okay, so this is a capital M and this is a small m. So distance between them from the centers, let me take it as R. So now you can see what is the question is, what is field due to the point mass? Sorry guys, small m. So what is the field due to the small m? That is what we have to calculate. So field due to point mass is a small m. So how much it is? That is what we have to calculate it. So let us see. We all know force of attraction is equals to capital G into small m into capital M divided by what, everybody?
R square.
R square. Okay. So now, if you observe very carefully, they are asking due to point mass, small m. So we all knows that E is equals to, what is the formula? E is equals to, everybody, F by M. Understand that? F by M. So F is equals to G into small m into capital M divided by R square divided by M. So mm will get cancelled. So what is the formula, everybody? Capital G into capital M divided by R square. So this is the formula actually which is always act. You can see the force of attraction of a small body is always acting towards the what? Towards the bigger body only. Am I right or wrong? Please respond, guys. The bigger body is trying to attract the smaller body in this direction, and smaller body will attract the bigger body in this direction. So always this force of that the gravitational field E, which is always acting towards to the mass, towards to the capital mass M. So if I take this is a forward is a positive means, then backward due to the small m is a negative or positive due to the small m. Everybody, it is the negative. That is what you have to remember. So capital G into capital M divided by R square, which is acting, a small m is acting towards the capital M, is always opposite direction to capital M on small m. That is why it has been taken as a negative. So this is the field due to a point mass small m on capital M. So that is what you have to remember. But if I take, suppose, field due to a mass capital M, then it will be reversed. So what will happen by the time? E is equals to F by M, capital M. So G small m divided by, so small m into capital M divided by R square divided by capital M. So mm will get cancelled. So effect of field due to the capital M is equals to G into small m divided by R square. But it is a positive or negative, everybody? A bigger mass is acting forward direction on smaller mass. So it is a positive or negative? Forward direction. It is the positive. You understand it? But the force experienced by smaller mass force experienced by bigger mass due to smaller mass is always acted towards to the bigger mass. So that is why it is considered as a negative. That is what you have to remember. Understand, Narayan? Rudreswa? Clear, everybody? Please respond, guys. So this is what is field due to the point mass small m. Field due to the point mass small m. Okay, everyone, clear? Understand?
Yes, sir.
Yes, sir.
Clear? Any doubt you can ask. Okay, guys?
Yes, sir.
That is one. Now, you can notice it. For example, there is a two things all of you observe very carefully. Let me take two masses whose mass is m1 and whose another mass is m2. So both are actually connected to a point. Let me take P of a r1 distance and of a P it is r2 distance. Now they are asking what is the gravitational field on this point due to these masses. That is what is the question. Everybody, can you say it? Anything? So it's very simple. You can notice it. Anybody? Anyone? Pradosh, Traira, Rudreswar? Yes, Rudreswar, there is a concept which we studied yesterday's class. You have to use this. What is the concept yesterday we have used? Principle of? This is the point. It is experiencing two forces. You can see that. What is the two forces? This point is experiencing due to this one. Let me take E1. And this point is experiencing due to this mass is E2. So now, what is that they are asking? Total. So then what will happen? E1 plus E2. That's all it is. You understand, everybody? So between them, what is the force of attraction? G into M1 divided by F is equals to, E is equals to G into M1 divided by R1 square. And here E2 is equals to what? Everybody, G into